This video shows how easy it is to set up a custom image analysis pipeline in ZEISS arivis Pro for 3D organoid analysis. The goal is to count total cells and in the organoid and classify them as either GFP positive cells or RFP positive cells. And to do this, we're going to build a pipeline that uses a deep learning model for cell segmentation, followed by a machine learning model to classify cells as either GFP positive or RFP positive. So let's get started. To open a file, click on File, Open, and select the file. And this is a 3-channel image. And on the right-hand side, you can actually check and uncheck these boxes to view a specific channel. And of course, DAPI is showing us all nuclei. This is the Z-slice, and sliding this slider shows you specific slice, and that gives you a better understanding of the data set. Let's start the analysis by clicking the Analysis panel on the top, which opens this panel on the left-hand side. And let's click on New Pipeline. The first step here you see is a selection of a region of interest, and we're going to use the current image set, which means any operation that we are going to do later on is going to be applied on this entire image set. But if you work on very large data sets, you may benefit from actually selecting a small subset of that data set while you're setting up the pipeline. Of course, you can run the pipeline on the entire data set. So let's leave the current image set and let's add the next operation, which is segmenting the nuclei. And you can search for a specific operator, or in our case, let's go and look under segmentation, simple threshold. We don't want threshold segmenter for this. We want something that's a bit more smart. So let's add Cellpose-based segmenter, which is a deep learning-based segmenter. And each of these operators come with their own set of parameters. So the first one for Cellpose is the channel that it's going to use as the primary channel for segmentation. So let's pick DAPI. And we also have a selection of pre-trained models to pick from. So let's go ahead and use the default CP for now. For cell diameter, approximate cell diameter, you can actually make a measurement on a random object on the screen. In this case, it's giving us 8.96. Great, let's leave it. And just so we can identify the output later on as part of the pipeline, let's give it an appropriate name by calling it all nuclei. And finally, let's also change the color of the segmented result to show us all the nuclei in random colors. Now, we can run this entire pipeline by clicking this Run Analysis Pipeline button, but let's actually click on the right arrow, which actually executes the pipeline in steps. So let's do it once. This defines the ROI, and let's do it again. Now it started the Cellpose-based image segmenter. Now, the time it takes to actually perform the segmentation completely depends upon your local resources and, of course, also on the dataset size. In this case, it should be relatively quick, although I am working on a lightweight work laptop, and still the result should be almost real time, probably a few seconds. As soon as it's done, it opens up this object results panel where you can see the mean intensities. Click on an object to get specific corresponding parameters. You can open up more features, or you can display more features by selecting them under feature columns at the top of this objects panel. But for now, let's not look at intensities because we are not using intensity-based classification of these objects. We are using machine learning-based. So first step, let's go ahead and store all the objects that got segmented using Cellpose, along with all the metrics. Now we're going to use intensities, not directly, but we're going to use intensities to train a machine learning model, which is what we're going to do in a second. So to do that, go ahead and click on Analysis and select Machine Learning Trainer Objects, because we already have segmented objects. You can add more classes, but we have 2 classes in our case. So let's change the class 1 to GFP positive. Let's copy this name so we can type it, paste it here for class 2. Class 2 is RFP, so let's paste and change the G to R. Okay, there you go. So we have RFP and GFP. These are the 2 classes. Now, to add training data, first of all, let's go ahead and change the transparency so we can, opacity, so we can actually see objects, see through these colors. And now we can clearly see the green ones versus the red ones. So let's go ahead and click on these, add, Or hold the control button down, click on multiple. Let's click on all the ones that we know are part of GFP. Go ahead and add. And let's actually turn the DAPI off for better visibility. Now let's select a few more green, maybe in the periphery, because these are the tough ones for the model to segment. And now let's go ahead and add a few of the red ones under the RFP positive. So let's hold the control button down, click. Let's select a few more. We can get started, and if the model doesn't do well, we can add more from where the model is not performing well, right? So let's go ahead and hit the train button. Oh, one thing I forgot, sorry. We are actually training based on size. We don't want that. We want to train based on intensity. So let's go ahead and select intensity here and then hit train. And once it's trained, let's go ahead and run on the entire data set to actually see the result. And that does not look bad, except there are a couple of these objects that I think should be part of GFP and not RFP. So let's go ahead and add them and go ahead and train. Training should be super fast. And this is because this is just a machine learning and not a deep learning model. Okay, I'm satisfied, I'm happy. Let's open this in the pipeline and let's run the entire pipeline. You can do step by step, but entire pipeline. And there you go, amazing result. And switch the view to 3D view and go ahead and explore the objects. So I hope you learned how easy it is to customize image analysis pipelines using ZEISS Arivis Pro. Thank you.